in this section, we're going to talk about two theorems. We're going to talk about Hero's theorem or formula, and I guess this person is Indian, Brahmagupta's theorem. And they're both techniques to find the area. Well, one is to find the area of a triangle with just the three sides, and the other one is to find the area of a four-sided polygon with just the three sides. Heron's formula goes like such. If you have a triangle and the three sides are known, say A, B, C, then the area will be the square root of S times S minus A times S minus B times S minus C. And you all should be saying, but what's S? Where S is, well, you add up the three sides and you divide by 2. I want to see one thing. Actually, this guy was Hindu. Well, the four-sided figure. Okay, so basically, you have a four-sided figure, A, B, C, and D. And the area is going to be very similarly defined. It's going to be S times S minus A times S minus B times S minus C times S minus D square root. Where S is A plus B plus C plus D over 2. Always over 2. Okay. So basically, you add up the three sides divided by 2, and now you have S. That's one of the factors. And then you do S minus this side, S minus that side, S minus this side, multiply them together, take the square root. For example, if you are given a triangle, 3, 4, let's make this 2. 2, 4, here, make it 10. Now I'll be happy. 2, 6, 10. Oh, that can't be. Just want the numbers not to have a fraction. Just want the numbers to work out nicely. What about 3, 5, and 6? I mean, we don't have a choice. 3, 5, and 6. Find the area. Okay, so S is 6 plus 5, 11, plus 3 is 14 over 2, which is 7. So that's one of the numbers. So we call this A, this B, that's C. Doesn't matter. S minus A, 7 minus 6 is 1. S minus B is 7 minus 5, which is 2. And S minus C is 7 minus 3, which is 4. So we're done. The area is, you multiply those four numbers, 7 times 1 times 2 times 4. You take the square root of it. Now, the fact that I know the square root of 4, I'm going to break it up that way. It's the square root of 14 times the square root of 4. And I know the square root of 4. No point in multiplying it in, getting 56, and then say, oh, 4 goes in there, and I know the square root of 4. Now, 14 cannot be broken down, so the area in simple form is 2 square root of 14. Now, what if the three sides were 3, 4, and 5? If the sides are 3, 4, and 5, I think you should remember it. 3, 4, 5, right triangle. The area is over 2. It's the base times the height. Since that's the right angle, that is the height. The answer is 6. 3 times 2. But we can use the Theorem's formula. S is 3 plus 4 plus 5, 12, over 2, which is 6. Right. Okay, now, S minus A, 6 minus 3 is 3. And S minus 4, 6 minus 4 is 2. And lastly, always run out of room on the last one. S minus 5 is 6 minus 5, or 1. And you multiply those four numbers and you take the square root of it. The area is 6 times 3 times 2 times 1. Multiplying by 1 you don't need to do. Look for perfect squares. Remember, the square root of 17 times 17 is just 17. And the square root of 631 times 631 is just 631. And the square root of 48 times 48 times 5, well, the square root of that product is 48 times the square root of 5. And I see a 6 there. And I see a 6 there. The square root of 6 squared is 6. Now you want to multiply it out and go 6 times 3 is 18, times 2 is 36, and the square root of 36 is 6. Go for it. But you're still going to get 6. Let's try another one like this. Then we go on to Brahmagupta's theorem. A Hindu mathematician. 3, 7, and 8. You have a triangle. The three sides are 3, 7, and 8. What is the area? Well, S is 7 plus 3, which is 10, plus 8 is 18 over 2 is 9. Then you do 9 minus 3, you do 9 minus 8, and you do 9 minus 7. And you multiply these numbers. The area will be the square root of this product. 9 times 6 times 1 times 2. That's some number. The square root of 9, the area is the square root of 9 times the square root of this number. But I know the square root of 9. I'm not going to multiply it out. And you know what? I see a 2 here, and there's a 2 in there. 6 is 3 times 2. Forget the 1. Times another 2. 3 the square root of 2 times 2 is just 2 times the square root of 3. 6 square roots of 3's. You want to multiply this out and get the big number, 108, and then say, you know what, I know numbers, I know my 36 table well. 36 times 3 is 108. How many of you knew that? So it's the square root of 36 times the square root of 3. And personally, that's how I write the square root of 36. And I got the same answer. And I didn't deal with the 108. I didn't have to figure out that 36 went into 108. That's way, way too complicated. At least for me it is. Okay, now we change the game around a little bit. I give you a 4-sided figure. 2, 6, 7, and 9. 2, 6, 7, and 9. And I ask for the area. So first we have to find S. S is 2 plus 7 is 9, plus 6 is 15, plus 9 is 24. Over 2 is 12. Now you do 12 minus each of the sides. 12 minus 6 is 6. 12 minus 9 is 3. 12 minus 7 is 5. And 12 minus 2 is 10. And let's not forget that S is 12. So the area is the square root of that product. It's the square root of this product. The area is the square root of 12 times 6 times 3 times 5 times 10. And what you want to do is get the same number in there 2 times, or 4 times, or 6 times. Now, you might say that that's 5 times 2. So, I have 2 5s, and you know what? 3 times 2 is 6, and I have another 6. And 12 is 4 times 3. And I know the square root of 4. So the square root of 5 times 5 is 5, times the square root of 6 times 6 is 6, times the square root of 4 is 2, times the square root of 3. I don't know what that is. 5 times 2 is 10, times 6 is 60, times the square root of 3. The only problem is I told you the wrong formula, sorry. The area is the square root, but it doesn't have S in it. It's just S minus A, sorry about that. S minus B times S minus C times S minus D. Where S is A plus B plus C plus D over 2. That is, we don't need the 12, sorry. We don't need the 12. So, let's just do it again. It's the product of those 4 numbers. 6 times 3 times 5 times 2. Sorry, times 10. Okay, so we just don't put S in the formula. So it's a little bit different than here on this formula. Okay. When I see 6, I see a 3 in it. 6 is 2 times 3. Times that's 3. Times 5. And in that 10, I see a 5. The square root of 3 times 3, the square root of 9 is 3, plus the square root of 5 times 5 is 5, times the square root of 2 times 2 is 2. And when I multiply those numbers, I get 30. 5 times 2 is 10, times 3 is 30. So, earlier on, at the very, very beginning, where I wrote down the formula, it shouldn't have the S. Sorry about that. Okay, shouldn't have the S. In Heron's formula, it certainly does have the S. The S is certainly there, but not in Brahmagupta's theorem. So it's very trivial problems. Know the formula, unlike me, know the correct formula, and then you can work it out nicely. Let's try one more problem. Suppose you have 5, 7, 4, and 10. You have a 4-sided polygon, quadrilateral, with those 4 sides. What's the area? Well, first we need S. You add them up. 12 plus 4 is 16, plus 10 more is 26. Divided by 2 is 13. So now you do 13 minus each of the 4 sides, and you take the square root of the product. 13 minus 5 is 8. 13 minus 7 is 6. 13 minus 4 is 9. 13 minus 10 is 3. So the area is the square root of 8 times 6 times 9 times 3. Now I'm not going to touch the 9. And there's a number that I know the square root of that goes into 8. It's called 4. 4 times 2, that's 8, times 6, times 9, times 3. Well, I know the square root of 4. I know the square root of 9. And look here. 3 times 2 is 6, times another 6. I know the square root of 4. I know the square root of 9. 3 times 2 is 6, times another 6. If you insist, 36. I know the square root of that. It's 6. The answer is 6 times 6, or 36. You multiply these numbers together, you're actually going to get 36 times 36, which is 216. 3 times 36 is 108. You get 1296. How many of you walk around knowing the square root of 1296 is 36? Personally, I don't. If I did, I wouldn't have just multiplied it out. So, let's do 1 or 2 more problems. And I'm going to try for these problems that actually have a problem. Find a triangle whose 3 sides are 2, 5, and 7. You have a triangle with those 3 sides. Find the area. Well, the area is routine. You add up the sides, you get 14. You divide it by 2, you get 7. Now, Heron's formula actually has 7 in it. So, S is 7. Then you do, S. And then you do 7 minus 2. You do 7 minus 5. You do 7 minus 7. And you take the square root of that product. And of course, so it's the square root of 7 times 5 times 2. Which is a number? You want to figure out what number it is? Figure it out. But you know what? When you multiply it by 0, you're going to get 0. The square root of 0 is 0. Then you're like, how can the area be 0? Well, remember 2, 5, and 7. If one side is 2 and the other side goes immediately to the left and it's 5, well then yeah, that third side would be 7. But it's not a triangle. The third side can never add up. The longest side can never be the sum of the shorter sides or more. Like, you couldn't have 2, 5, and 9. If 2 goes to the right, if 2 goes to the right and 5 goes up this way, this is going to be shorter than, every time I make this angle bigger, but I still live up to the 2, 5, this third side gets bigger. If I make it even bigger, still 2 and 5, this third side is bigger than this one. And as you get really, really close to 180 degrees, maybe this is 179.9 degrees. This is 2, this is 5. This third side would be 6.9993. Get really close. It can never be 7 or more. It can never be 7 or more. So that is why the area was 0. You have one side that's 2, you have the other side that's 5, 180 degree angle, and the third side just lies on top of it. So basically the area is the base, 7, times the height, which is 0. So here the area really, really is 0. But now we can even find a worse case than 0. That answer is correct. If you insist, well, not if you insist, if you were allow this to be a triangle. If you allow a straight line to be an angle, then it's okay. Now, if you have 4, 6, and 12, these are the shorter sides, and they only add up to 10. How can the third side be more? This time, we definitely are not going to get an answer. S is 4 plus 6, which is 10, plus 12 is 22. Divided by 2, you get 11. So S is 11, and then you do 11 minus each side, one by one. 4, 6, and 12. This is 7, this is 5, this is -1. So the area is going to be the square root of 11 times 7 times 5, a positive number, times -1. That's negative. 35 times 11 will be 385. Times -1 be the square root of -385, which does not exist. Like I said earlier, a few minutes ago, if the two shorter sides, 4 and 6, if I make it almost 180 degrees. That third side would be, around 10. And that's the longest it can be. You can't get 12. So here, this is not possible. In the last problem, I forget what it was, but we can go back. In the last problem, 2, 5, and 7, it's it's questionable if you want to say if it's possible or not. It really comes down to how you're going to define a triangle. Okay, this is a collapsed triangle. Here are the two vertices. Here are two of the vertices. The third vertex is, let me think. Well, yeah, it's right here. It's somewhere on the line. In other words, here are, well, what's troubling me? You have one ray, you have another ray, and there's the third one. Okay. It turns out that the third side is on the first two. Now, if you want to call that a triangle, then yes, it's a triangle. The area is 0. If you want to say that's absurd, then you say it's not possible. And, just ask your teacher whether he or she will allow the triangle that's collapsed, that is, whose area is literally 0. Okay, that finishes this short and quick chapter or section. Actually, the chapter as well. Okay, study hard. Good luck.